Okay, with this question here, basically everything's going to be done using the binomial distribution. So if you're looking for one specific value, one specific outcome, and that'll make more sense once we start doing examples. That's going to be a binomial PDF. If we have a range of outcomes, that's going to be binomial CDF. The thing to keep in mind is that when you're doing binomial CDF, it always gives you values less than or equal to something. So if I said probability of something, we're talking about x has to be less than or equal to 4. Okay, that's going to be a binomial CDF. If you're trying to find the probability of it being greater than 4, you're going to have to find what would be to be less than 4 and subtract that from 1. Okay, because you can only go in the one direction with binomial CDF. So this is a manufacturing machine has a 6% defect rate. If 10 items are chosen at random, what is the probability that at least one will have a defect? So we want to know the probability of at least one. So that means 1 could be defective, 2 could be defective, 3, 4, 5, all the way up to 10. So you can find each of those individually and add them up if we want to use a binomial PDF. I think that's crazy. So what I'm going to do is just say, all right, well, what's the only other option here? At least one. The only other thing that we could have would be no defects. So I'm just going to find the probability of no defects. And since I know that's the only other outcome I can have, I'm just going to subtract that from 1 to get the complement. At least there's one defect. So I'm going to go into my calculator, my distributions menu. This is a binomial PDF because I'm only looking for the case where there's no defects. Trials is 10 trials. They have a defect rate of 0.06. Right, I just want to get that right. Oh. Yep. And I want to know the chance that there are 0 defects. All right. So I get this outcome. But again, I want 1 minus that to get the probability of it being at least one defect. So I get 0.4614. And that's going to be your answer. Or again, you could say find the probability of 2 defects, find the probability of 3 defects, 4, 5, 6, 7, 8, 9, and 10, and then subtract that. Add those all up, and you should get the same thing, 4.4614.